So before we start recording, Jessica, in just a minute, we are going to do the whole routine so they have a recorded copy of our workshop. And but depending on what your emphasis is, you may hear some things that are beyond or below your grade level, those kind of things. So just to let you guys know.
Oh, excellent. We have more people.
So as you're coming into the room, if you want to use the chat feature to let us know what district you're from and possibly what grade you teach in content area, that would be helpful. Just as we're presenting, we can customize it a little bit as we see your grade levels.
All right. So, see, I put your hand down, Jessica. Good morning, everyone. So we're working on a new platform and we're having some bandwidth issues. So if you can't hear us and we think we're talking, we look really animated, please let us know in the chat so we can either tag off or one of the two. As you can see, we're in our office and we have our masks on, so I hope that you can hear us appropriately. So good morning and welcome. We are really excited to have everybody here today. All right, we're already with. So my name is Melanie Jansen. I am one of the math coordinators at San Bernardino County Superintendent of Schools, and I have my partner in math, Catherine Vittorio.
We're excited to be here and share this routine with you that works across content areas and grade levels. So let us know if there's any way that we can help you as we do the presentation.
All right. So today's agenda, we're going to talk a little bit about our 21st century learners, which is so important right now, especially when we're looking at the landscape of everything is changing right now. We're going to also talk about standards for mathematical practice and the science and engineering practices and how they work together. And then most importantly, we're going to get into that focus on the question routine and how you can use that tomorrow in your classroom. And then we're going to give you some resources for tomorrow.
So when we think about our 21st century learners, what skills must our students have as those 21st century learners? If you would just add skills to the chat box, what skills do you really want your 21st century learners to have and be able to use? Absolutely, the ability to collaborate, Jolene, be risk takers, critical thinkers. Absolutely, that critical thinking is huge. Collaborators, critical thinkers, absolutely. Asking questions is powerful, and we know we become better at question askers, the better the questions are asked of us, right? So we model that as educators, communicators, problem solvers, having that ability to persist in problem solving. Absolutely. So when we think about that, and your responses are right on, we look at a study that Hanover did, and they presented some characteristics, traits, and qualities that we want our 21st century learners to have. And they organized them a little bit differently than we see in some research. They put them into 3 tiers. And in tier 1, we had those things that you guys are mentioning, that ability to collaborate and work as teams, be creative, and you have an imagination, be critical thinkers and problem solvers. So those top 4 are the first tier. In the second tier, they identified the flexibility and adaptability, global and cultural awareness, information literacy, and leadership. So we know that those are also very important characteristics that we need our students to have. What was a little bit different for me is this third tier, because they went down and they compiled this information and they talked about civic literacy and citizenship, an ability to write and communicate, right? And speak and communicate with those communication skills overall. And we know how important that is, especially when messaging, when communicating, when sharing data. We know how important those things are. They also talked about social responsibility and ethics, a technology literacy, and taking initiative. And we know that this was done in 2018. This information was compiled in 2018, and all that was only 2 years ago, which probably seems like 15 years ago. 2 years ago it does. We know that there may be some displacement on this list and moving around and some fluidity, and we know that technology may have risen to a tier above or 2 tiers above, and we know that. But these skills, this is still the skill set we want our students to have and possess. And what we know is when we look at those skills, the practices in math, they're a set of our standards. They're probably our first set of standards, our standards for mathematical practice. That's the how we engage in the mathematics. And we have those science and engineering practices as well. There is some overlap between these two. But bottom line is we want to leverage routines that help support and build these skill sets in our students as much as possible. So when we look at some of the comments that you guys made, opportunities to investigate or to persevere or to communicate or collaborate, all of these things, ask meaning and purposeful questions. We want our kids to be able to look for and adapt to those patterns and learn from what they've done and apply those reasonings and the critical thinking skills and those kind of things. We want them to be able to model with mathematics and or in science and engineering. We want them to be able to do those things and be able to communicate. So our practices become paramount in what we put before our students and how we present the content.
So in thinking about that and the skills that our students need, we really want to think about how do we ask questions? How do I ask questions as a teacher? How do I ask questions as a learner? So these help me think through some things, right? And this is not just for math, not just for science, but really in life. So when we think about the question process, the thinking process, what is the problem even asking, right? That's a life skill that we need to think about. Like, what is this problem asking when my whatever's broken in my house? What do I need to do? How do I begin? What do I need to know? And what do I do with this knowledge or with this data? And then we're going to try it again. Did my plan work? Does it make sense that this is it really supposed to fit this way? Or does this answer of 100 million look really right? I don't know. And do I need to go back and try a different strategy? These are life questions that we need to encourage with our students in the classroom. So how do we get there, right? So thinking about asking ourselves these questions, like in our classrooms every day, how do we build critical thinkers? What opportunities do we have for them to be able to respond to questions like this? And how do we keep our students actively engaged in solving problems and solution designing? I love that terminology, solution designing, because that's really what we need right now, especially in 2020 and beyond. We need some solutions for sure. And then how do we help our students develop that positive attitude and perseverance, right? Instead of saying, oh, there's fractions, I can't do it. Oh, there's too many words, I can't do it, right? And so we help them develop that perseverance that they so desperately need. All right. Oh.
So focus on the question is, on the question. Let us get back here. We just got to figure out, we're just navigating our way through this.
There we go. Being 21st century learners.
Oh, go ahead. It's student expectations, Melanie. Mm-hmm. Sorry.
No problem. So we want to make sure that we have these high expectations for our students. We want to make sure that they are able to determine and articulate the problem, not let me spoon feed it to you, but that they become independent learners, right? Especially in this day and age, we have to help them be independent learners because they're going to be by themselves and a little bit self-directed. So how do we give them those skills and those tools that they need to be able to go and soar? That's really what we want our students to do, right? So they want to find a starting point by understanding what these mathematical situations are and figure out what is relevant and what is not, and what would be appropriate pathway. So should I try it this way? Didn't work, let me try another way. And then they can start connecting their problems and then identify different ways to solve problems and making more connections. I tried it this way, it worked that way. I tried it this way. This might be more efficient, but it still works. So getting students to be aware of what they're doing and working on that metacognition as well.
So in this day and age, it's even more prevalent than it has been in the past, is that the routines that we select to use with our students need to leverage the development opportunities and learning pathways for our students that are most important. So focus on the question is a simple routine that addresses multiple problem-solving skills, many of which we talked about as 21st century skills, and does really, truly, and honestly require little teacher prep, which I think is a plus. And it fits into a minimal class time and does not require any additional paperwork or inputting into a grade book or that kind of thing, because the whole essence of this routine is to get our students thinking and analyzing and communicating with one another and interpreting and all these valuable skills that we know. It provides an ongoing problem solving experience for students at all grade levels. So when I look at leveraging a routine that can go K-12, actually K-16, actually K-Life, it's focused on the question, because the way we can do this, it's an opportunity and a routine that's easily integrated across various content. So whether you're a math teacher, a science teacher, a K-5 teacher teaching all of areas, content areas, you're going to see that this routine is something that you can do. And it's a strategy that allows our students to explore and review specific content skills through that problem situation. So what we're going to do is we're going to jump right in here, and we're going to ask you a question. And the question we're going to ask you, Melanie has launched a poll, so you should see a screen that pops up, and it's asking you, what is your favorite color of jelly bean? So just go ahead and amuse us and submit an answer to what your favorite color of a jelly bean is. We're going to give you just a few seconds to answer that poll. In the various platforms that we're using right now for distance learning, we have poll opportunities in some of those platforms. So we just wanted to model one way that we could collect some data. We could also just present data to our students, and we'll model that as well. But we just wanted to show you that we can do that. So just wrapping that up, Melanie, can you see how many responses we have on that poll?
We've got 29, so we're pretty close.
Okay. So with that, what we're going to do is we're going to show you the data from our training, what we saw, and then we're going to show you how we have used that data to share with our students and the kinds of questions that we've asked them over the course of a week. So there are things out there right now called data talks, and I love Joe Bowler's data talks, and they happen in 5 to 7 minutes in a classroom once a week. They can be extended to take on a more of a focus on the question type of design, still keeping that integrity of a data talk. So we like focus on the question because it is a routine that happens over the course of a week. In our distance learning classrooms, it might be 2 to 3 days a week for that 5 to 7 minutes where we engage our students in a variety of ways of communicating it. So can you share the data with us, Melanie?
I think I can. You see it?
I cannot see it.
Well, let's see if I can push that out. Can
Yes,
you
now I
guys
can
see it?
see it.
Okay, there we go.
So what our data is showing us is out of the number of responses we had, right? You guys can see we had 32 people respond. My data set just changed. So I can't actually see the data that we had. So I'm going to go forward with what we had in our presentation, and then if people see that data, we can do a comparison. But if I had done something similar and collected data from my students, for example, on the same way we did, I would present my students with a poster or a slide in the distance learning classroom that presents that data to them. And I would just let them, first of all, take the opportunity to engage with this data. And we always want to teach, especially our younger students and our younger learners, how to make sure that we take in the whole picture, the whole slide, the whole set and table of data, right? So we would want to teach our students the idea of scanning from top to bottom, bottom to top, left to right, right to left, making sure that they've taken into consideration all the data. So once I do that, I want to engage my students in this, let them have some notices and wonderings. And so very often in Focus on the Question, the first two questions that we ask our students are, what do you notice? And what do you wonder? And as a teacher, by design of this routine, I'm going to be posing a question to my students every day. They're going to come back to the same data. They're going to make sense of the data. They're going to engage with the data. They're going to work with the data and do some interpretation. So having them come up with some questions. Remember, we talked about how valuable it is to be question askers. I could even embed some of the questions that the students have asked into, I can embed some of those questions into my week if I want. So step one was just to post it, let the students see it, explore it. Step two would be to each day pose a different problem or question in which the students must use some of the data to interact, right? And so we know that that's valuable. We know that on the next step, what we're going to do is we're going to start asking our students about the data and the complexity. So this may be a question asked in elementary of which was the most popular jelly bean. And so the students are going to interact with that question. It may be, how does that compare to your choice? So I may have them do a turn and talk with their partners in a physical classroom. In a virtual classroom, if I had breakouts, I may put them into some random breakouts just for those conversations. And or I might just, depending on the platform my district is using or that kind of thing, I might just have them use the chat box. If it's a group is small enough, I might even actually have them unmic, because I think all of those are valuable. So at this point on the second or third day, we're looking at what's most popular. We're going to interpret that. We can use different vocabulary. How does that compare to our choice? So we can do that as well. When I think about the next step and the next day, the complexity of my questions will grow depending on my students, and ultimately the end that I had in mind will be unfolding, and I'm giving students an experience day by day that will help prepare them for that. So in this day, we see the question being, Bryce wants to share her jelly beans with her friends. Each friend must get an equal portion. So how many friends can she share her jelly beans with? Is there more than one solution? So what I really like about this as an educator is that obviously we know quickly, yes, there are more than one solution. I know that my student is going to need to use some way of counting and determining how many jelly beans there are in all. That may have already happened in a previous question, depends on the student. And then the student starts to think, well, I really only want to share them with, Abby and Kelly. So no matter what, I'm only going to share them with 2 other people. So those students may each get 10 or 11 or 9 or whatever it is, depending on how many students they come in. But letting the students sit with that for a minute and then start to hear other solutions. Well, what if I only shared it? I shared it with 12 friends. How many would each get? Well, what if I shared it with 4? And the students start to hear different solutions, and it really builds that idea that there are multiple solution pathways, especially in problem solving. And so we are building that skill in our students as well. The next step is that we want our students are not required to provide an answer. So some students may just sit with their thinking. Some students may feel comfortable sharing it in small groups, but they may not want to yet feel comfortable bringing it to the whole group. So we want to encourage them to think and possibly dialogue with at least one another, right? If not more. And so depending on the platform that we're using, sometimes probably my favorite way was just pair share in the physical classroom, and I would use breakout rooms to do that still, because I think that voice is important. And I also think it's important for students to have the opportunity to learn from one another. So anytime they can talk to each other, I find that very valuable. So today the question would have been in this progression, how many jelly beans were in the bag? Remember, we counted those yesterday, so that should be a pretty quick recall. Can you explain a strategy for determining how many there were without counting each jelly bean, the X marks? If you were the student who counted one by one in this second grade classroom, can you start to think of a different way? And so now what I'm having the students do is start to think of some strategies they know and apply those strategies and those kind of things. And there's great value in that and we recognize that. So we keep this question available to our students. In the physical classroom, I literally used to make posters and just put them up so that students can visit them and start to make sense. I also always had Post-it notes and a marker nearby. If they wanted to ask a question randomly during the week, they could do that, and other students can come by and visit it and provide answers. Well, that could also then transfer easily to the virtual classroom as well in some of our assignments that we can offer and share in Google Classroom and those kind of things. So in a nutshell, basically what's happening is that the data is presented, and then we unfold the questions that we're asking our students to interact with. So in step 1, we posted that data, and it remains available to our students all week. Each day we pose a different question or problem. We provide opportunities for our students to talk. That is very important. Everybody was mentioning collaboration. as we were unfolding what skills we need. And we know that them just talking through it, and you'll see with some of the examples, the talking becomes more prevalent and necessary to come to some solution pathways. We facilitate a classroom discussion based on some of the overhearings that we have or some of the comments that were made in the chat box. As the teacher, we facilitate that conversation. And what we bring and elevate into the classroom as a whole is very important, right? We have an opportunity to bring student voice in and elevate student status with what we're doing. So we need to be cognizant of that as well. I love it because we want to keep in mind students are not required to write. Could they? Sure. But they're not required to. And I think that takes down some of those barriers that some of our students always feel that work has to result in a writing exercise. It's really about the dialogue and the learning from one another. And ideally, this activity is to take somewhere between 5 to 10 minutes. Most of us are familiar with number talks. Data talks and focus on the question is the exact same design. So I often start with just a picture in the virtual classroom and tell my students, for example, I always plant a garden every year. And this is some of the things that you may see that I plant in my garden. This is the same slide that I can show in a kindergarten room and ask them, what do they recognize that I'm going to plant this year? All the way to an 8th grade class if I wanted to when I'm talking about some different things. And you'll see the visual that goes along with this for the focus on the question becomes this. And I tell my students when I mapped out and designed my garden, these pieces represent the area for each of the things that I put in my garden. So just seeing that and knowing the grade levels that you teach, just kind of let that sit for a moment. What question could you ask your students about this picture? Because this does represent data, right? It just doesn't in the traditional sense of what us thinking about tables and that kind of thing, but it's absolutely an area map of my garden. So what's a question that you could go ahead and add some questions to the chat box, if you would, as we continue to have our conversation. As I'm planning my questions as the educator and the facilitator of this focus on the question, I always want to know what my end game is. What do I want my students to take away? What skill am I developing? And so I'm just going to put out there my skill that I was developing and putting this in front of my students had to do with coming up with unit fractions. And so I ultimately wanted to build their capacity and their engagement in this area map of my garden to build the idea of unit fractions. So we could absolutely take it to an idea of how will these interact? Why did I choose what I chose to plant where I did? I ask my students always on the, I went as simple as in my 2nd grade class when I did the same one, which wasn't the intent, and that one was not about the unit fraction. But I just asked them, what part of my garden is made up of tomatoes? It was really about them noticing that there were multiple types of tomatoes. So there's a lot of things that we can extract from this. But ultimately, in that 5th grade class, when I was talking to those students about a unit fraction, I really wanted them to be able to make sense of it. So I layered my questions from Monday to Friday so that by Friday, they were prepared to tell me what each of those unit fractions were for the areas of what was planted in my garden. This is a similar one.
Wait. So going back, so I'm looking at some of these questions. These are amazing as we connect the math and the science. And why do some of these plots take up more space? So if we're talking about, I know that the zucchini is a squash and it spreads, right? And so I can talk about the ratio of or the proportionality of how much space it takes, and so it will require this much area. So now I've got measurement and geometry, I've got some science and how things grow and live, and so we're making sure we're combining, and we can take some of these questions too that we see with our students to help make it more meaningful for them.
Absolutely. And I think I love the way that this question definitely has a science overlap. It could go with a story that we read in our literature. There's a lot of overlaps that we could have here. I love the idea of why do certain things get planted? Why are we only have one, small portion of our areas, for example, is onions? And why did we choose to put garlic between the onions and the chives? Like, So these kind of things and those kind of questions really actually can set off a whole inquiry, right? So as to why students want to do certain things with their gardens. So absolutely. And I think taking it even further and having them take, once they've had some interaction with it, and going beyond and turning some things into graphs and tables and those kind of things could absolutely work to support that. We know with if my goal, for example, in that 5th grade was unit fractions, I could then bring the next week, we're all familiar with tangrams. I could then apply it here, but even take it further, right? Just by shading that one square in the center, I could ask them all kinds of questions. What shapes, for example, could you use to construct exactly 1/2 of this figure? Those kind of things. What shapes could I use to construct at 1/4? And I need at least 2 shapes. And having the students just interact with some things like that is very important. And just to have them, so what my point was with this one is it doesn't always have to look like a graph or a chart. It can look like something that they see every day, but that they can make sense of it. And they can really take the skills and the content that we're teaching them and apply it to something that they're familiar with. And then they start to get a connection to that. And they start to see and use that structure that they've been taught in different things and apply them to something that they deal with on a regular basis.
So now taking a look at this one, here's a nice graph that we can use in either math or science, right? What is it that you even notice and wonder about this, right? You get the kids saying, I see 2 graphs, they're similar shapes, and why are they similar? So we can have different kinds of conversations just about this graph in particular and spinning off on that. But then we can also take that graph and compare it with this one. So I've got average temperature range and average monthly precipitation. So where can I go with that? What information, what data is that giving me, and what questions does that lead me to? So then I can start asking, is there a correlation between the left and the right? And so as I see it going up, as the temperature goes up, my precipitation goes down. Why is that? So now I might lead to some more science questions, or I can talk about the amount of precipitation and the average, and what can we expect? Where do I do some water conservation? So lots of different ways to get students engaged and really thinking about, this is data that we see. This one came from Los Angeles County. So it's not some unknown something that was in the textbook, but this is something that is close to us and that we can relate to.
Okay. And this is for, some of our smaller students and younger students. As they learn, it's important that from the beginning that they're interacting with data as well. So this was just a pet survey. If they could have any of these pets that were in our story, which one would they want? And some of them even voted twice, and that's okay. It's just some data that we can use. And at this point, I can ask my students, I only have 10 cages, to transport my students to the pet store. How many trips am I going to have to take to the pet store if I only put one animal in at a time? And I allow the students to start to make sense of it, to come up with a plan, for them to argue that you can't put a fish in a cage so they can all go together. You're going to need a bowl. And so my students really got into this because they were telling and sharing what they knew. So the same cage that can hold one dog can only hold one mouse, Mrs. Vittorio. And I was like, no, my cages are different sizes. Like I had to think on the fly there. But the students were thinking of things that I perhaps hadn't even considered. But absolutely what I wanted them to do was to talk about which animal was chosen by more students, what was the least, and those kind of things, and just talking to them about some of the content and the skills that they use on a regular basis. Similarly, we did the survey with the students. We surveyed 3 kindergarten classes, and all we could do here was talk about the numbers. And we did that, but we used the same information to talk to 6th graders about ratios and proportional reasoning. We use the same information. What we may have done, though, at that point is we changed the graphic maybe, but it's the same idea, and the students had the opportunity. Sorry, Melanie, I'm totally taking your slide, but the students still had the same opportunity to engage with the survey results and those numbers. And so the complexity of the questions that we can ask obviously follows the level and abilities of our students, always wanting that stretch factor and always wanting those open-ended questions. So solution pathways can go in a variety of places.
So here's one that I find happens in my house all the time. I'm going to make some cookies, but we're limited on some ingredients. So why not bring that kind of conversation into the classroom? Like, what happens? Here's my recipe. There's fractions all over the place, but I only have half a stick of butter. What am I going to do with that? So having the kids really start thinking through it, because I know working with my child at home, okay, what do I do now, Mom? What do I do? So as she's working through and figuring out what does half look like, or I only have a third of this, just having the kids start thinking about it. Here's a real application of what I can use at home that I see right here in the classroom. And so using the idea of fractions and what do I see, and here's just another piece of data that we can use with our students.
Yeah, we asked the students even on this one, Melanie, how many solids do we have in our recipe and how many liquids do we have? And it started a whole conversation about things that were neither solid nor liquid. And they just started talking. I even asked the students on this one, how much sugar is in this full recipe? And the reason I asked that question, somebody goes, well, that's a very easy question. I go, it is and it isn't, because we have students that do not read full text. If you guys understand what I'm talking about, they start at the top, they see the word white sugar, and they're done. Okay, so they may not even get to the very next line that says light brown sugar, right? And so I also then had students say, well, can I count chocolate as sugar because it's basically sugar? Well, can you? And that started a whole nother conversation. So we always want to encourage our students top to bottom to top, left to right, right to left, scan the entire piece of information to make sure that we're getting as much out of it as we need and all the information. So I know that I've had many of my students, they're reading questions. I know they can do the math, but they fail in reading the whole prompt. So I think that's very important. And I think dividing recipes, I totally agree with you, dividing recipes. We did this one and we talked about doing it 1.5 times this. And what did that do as opposed to cutting it back or saying I only have 5 cups of sugar? Well, now that became 1 2/3 of a recipe. Well, how do you take 1 2/3 of 2 eggs? And so all of those conversations are huge. So this is absolutely one of my favorite things to do with recipes, and then even have them prepare it and taste it and see, did it turn out right? I mean, that's the ultimate test, right? Or you got to go back to the design process and change some things and try something different. So absolutely.
Modeling with mathematics. That's
absolutely
for sure.
Right. We do this with our youngest students, a bouquet of balloons, a pictograph. We know that if you miss the key on a pictograph, you are going to be not extracting the proper data. I told the students that these are the balloons I have, and they were for my after school club, and I needed to take them out of my car, but I didn't want them to all get tangled. So how many trips would it take me to bring the balloons in so that they didn't get tangled? Well, one of the students told me I was going to have to make a whole lot of trips because I should only bring in one at a time. And I was like, that is a lot of trips, but how many trips would it be? And so we just started having conversations after conversations. We had a conversation about, you know what, I got to the balloon store and these are the balloons that the students selected that they wanted, but they were out of orange. So what do you think I should do? And the students, they just hypothesized about what they thought we should do. We've had other conversations of how could I reorganize and get the same number of balloons, a same number of each color of balloon. And that was for my 3rd graders. And so they were doing something a little different, but a simple little graph like this allowed for our students to interact with the data and the content and then really start to apply some problem solving. We wanted to extract a few graphs that come from a curriculum. This just happens to be Go Math. We're not endorsing Go Math or anything like that. We just have access to them digitally. But throughout our curriculum, and we see graphs and tables all the time. This happens to be from 1st grade, and we know that we can ask a lot of questions about the coin value, the quantity of coins, and the total that we have, and some things like that. We can even use some of the questions, depending on what they are, what the publisher is putting forward. We know that this was another 1st grade graph, and it's very important that our students from a young age start to be able to read and interact with data tables, graphs, and those kind of things. So the kind of question that we put in front of our students, we could change this right here to be more than just one child if we chose to. But so when we say it's little prep, we're saying that there are graphs, tables, and data all around us. And you guys are going to be able to share your favorite place to get data at the end of our workshop. So be thinking about that. But it's as simple as snagging one of those images. This came from a fifth grade piece of chapter 2 in Go Math, and there's a lot of information on this table. There's a lot of questions as a teacher I could ask my students based on just this whole idea that Kevin's supply list for his saltwater aquarium. He may have so much money and he needs all these things. So how long is it going to take him over time? It can be as simple as he has this much money for fish. What combination of fish can he buy? So there's a variety of questions that we can ask our students that spread over a week and allow the students to interact with that data.
Or taking it to middle school. So here we're talking about rate. And so what does that look like? So if I have to go this distance, what does that look like for 100 miles that I have to go? What does it look like if I have to go 50, right? So having them just stop and think about what's happening here in this table. What do I need to know? What, could I figure it out for 15 miles? And so getting them to think and reason through some things without giving, here's a formula, but just letting to just stop and sit for a moment. What do you see about the relationship between the X value and the Y value? What do you see in the relationship between X values? What do you see about that? So just getting them to stop for a moment and think, and then we can extend. But this one came out of an eighth grade chapter. Then we have one from the from IM2. So we're doing some adding of polynomials. That's what this particular one was about. So can you write an expression that shows all of these? Can you write me an expression that makes an addition expression using these blocks? Can you write me an addition expression that equals these? So just having them, what do you even notice about these? So we're going to have to see that I'm going to have to add some positives and negatives and know that zero property, and getting them just to start thinking about what I can do and how do I look at it in the ways that we can represent. I have a picture, I'm going to need an expression. What does that look like? So I can put things together and put that ownership back on the students so that they start owning their learning instead of, I don't know what to do, she didn't tell me, but I'm going to put it back on you and work on that perseverance so that you can start owning it and you have confidence in yourself as a learner of mathematics or of math or of science as well. So those just are snippets that came out of, again, they came out of textbook just because that's the one we had access to. So then we took a little look at some other data pieces. So these come from, this one came from U-Cubed and from the data talks, which I really love. So we can have all kinds of conversations. I didn't want to pigeonhole this one because this is shifting incomes by age and education. So what do you see about these two graphs? This one on the left, this is the year 1966. And on the right, we have the year 2016. So thinking about your students, thinking about where they might go, what kinds of questions could you ask about this data? You go ahead and put those in the chat. What kind of questions could you ask, or what are you wondering about this type of data? These little lines here are the median incomes. And over here, this is the age group. So this is no bachelor's degree in 1966. In 2016, no bachelor's degree. We've got some dots over here. So thinking about, why do I have to learn this? Or looking at, this is for the age 35 and older. So we're having some great kinds of opportunities to think about the effects of my education. What does that look like? I can start talking about the statistics. I can talk about spread. I can talk about range. I can talk about the difference in the means. What does that do? So right here in 1966, those with a bachelor's degree between the ages of 18 and 34, that's a pretty big range. But when I look at it in 2016, the range is even greater. Why is that? So we have all these different conversations, but it's grounded in data. And now we can have some mathematical arguments about why things are happening. And we can back that up with data, right? So just when we think about science, you need to claim evidence. Here's the opportunity for us to take, there's our evidence, here's our claim, And this is our evidence for why we do that.
Yeah, and there was a comment, Melanie, on the other one of what is the difference in the number of blank from one graph to the other? And difference, and then I would go and say, what is the similarities? Like, so I think this is where there's one, where we can bring in a sister routine of same but different, and talking about those similarities and those differences. So I agree with Rosa. Those are some things that we could bring in just by having the valuable conversations there. So really, were you making more in 1966? Or are you making more now? You're making more dollars, but what about the value of that dollar? And I mean, just where these conversations can absolutely go, right?
Yeah, absolutely. Great questions. And then here's another one. This was the people who are working right now. So up the top, these are, and it's difficult for these graphs because there's so much information on them, and you want to get it all in. So how do you, where do I cut it off so that everybody can see it? But these are all the essential workers up here at the top. This purple is the percent who are women. So we have 48,710,000 total workers who are considered essential workers, and 52% of them are women. So now we have all these other things that we can talk about. Social workers, 78% are women. But how many is that? 2 million and some change. Healthcare, 77, 19 and some change. But then if we come down here, we got lots of different questions to ask, because are we talking what is the percentage in that sector? Are we talking about the number of women? So we have these conversations about what kind of data is important? The percentage, the number, the what? Is there a way that I can find two numbers that that are the same, but the percentages are different? So what is the best way to depict data? What is my purpose, right? So we're still going back to this claim, evidence, and reasoning, and what does that mean for me? And I can use the mathematics to prove it. Here's another one. This one comes from What's Going On with This Graph. It's a New York Times reference, and we'll share those references with you at the end. They have all kinds of data that comes straight from their newspapers or from their website, because this one is actually it's a graphic. It moves. So that's showing us here the average temperature from 1951 to 1980 here on the left. So what kinds of questions are you asking about this? Here's cold, here's normal, here's hot to extremely hot. Then shifting over into 2005 to 2015, here's cold, here's quote unquote normal, hot, and extremely hot. So looking at that shape, and we can kind of see in the background what 1951 to 1980 looks like. All kinds of opportunities for statistics. And then where is that going to take me? What kinds of questions can we ask for science? What kinds of questions can we ask for mathematics? And think about that. Why is it important to me now in 2020?
And even projecting what would the next set of data look like, right? If this is a trend, or if this is applying that same increase or change, what would the next graph look like? So there's a lot of places that we absolutely can go with this.
And how might I help shift it back this way, or talk about the standard deviation in comparing the two different graphs? Lots of different opportunities. So in creating your own, this is the beauty of the routine. Just knowing what your curriculum is, knowing your standards, you want to find a piece of a graph, data, something, right? We've gone all the way from student data. We've gone through snippets from their textbook. We've gone from their own data that I've asked my students. What's your favorite color? What's your favorite pet? How many people do you have in your household? All different types of things that we could get data from, or a recipe. And what is my purpose in selecting this data?
Did you freeze? So I'm not sure if Melanie is with us or not. Can you guys hear me? If you say in the chat box. Okay, thank you. So I'm going to wait for Melanie to come back. I think hopefully she'll come back to me. But basically, in a nutshell, we want to select and be intentional about what we put in front of our students, whether they can whether it's something that we're taking from something we use or something we're creating. Bottom line, we want this data in front of our students. So in the physical classroom, we create that poster. In the virtual classroom, I like to do it on a slide deck because I think students can then interact, and we know we have a lot of ways of getting students to interact. We could also just post it in our Google Classroom. There's a lot of different places, but be creative, be colorful, and be intentional. And then pre-plan 8 to 10 questions that we can ask our students. And it's very helpful if we collaborate. Just like we want our students to be able to collaborate, I love working with a partner on this because we think about things differently. We even see things differently, but it's all centered on that intention that I have in what I put in front of my students. I like to begin with the end in mind, i.e. that one where we're talking about unit fractions. And I might do those over the course of a few times because I taught those in September, but I want to keep that idea in front of my students so they get familiar with it and comfortable with it. And applying it, which we know is the greatest level, right? So when they can apply that learning to something. And we want to plan for extensions and reasoning and questions and opportunity for our students to interact with one another. The next part that becomes very important is generating what those questions are. Once I've selected the graph and I kind of know what my end game is, I want to generate some questions. So I am very much a post-note planner in the beginning as I'm just generating a bunch of questions, anything I could ask. I could even take technically some of the questions when I ask my students, what do you notice and what do you wonder? But I don't want to bank on that because I want to make sure I'm intentional in my pathway. So we can use those questions after we've done our questions and be able to do that. So I see, Melanie, you're back with us, right? I'm thinking Melanie is back with us. So once we've decided what we're going to do and we have our general courseway, we're in that planning process. And so what we want to do is make sure that we're now going to begin that question development. And I always like to start with what do you notice and what do you wonder? That's just pretty much a routine in my teaching, getting the students to have some kind of connection with it, and it opens up my eyes. We also want to develop questions that build upon one another. So I would not start, if you think about that garden visual, my area plan, my area model for my garden, I wouldn't start with, what is the unit of onions? Like I wouldn't start there. That's where I want to end. So I want to develop questions that help support one another to get me to that more complex situation. Develop questions that have that real world connection. And I want to, keeping in mind as I develop questions, what is my instructional goal here? What connections am I making to the content that we've taught? Or what am I wanting to put in front of my students from some prior learnings? So that I can even use some of their thoughts and some of their questions and some of their answers to help shape that pathway of what I'm putting forward. Developing questions that have real world context is always valuable to me. Beginning with that end in mind, that's that instructional goal. What would you want your students to be able to answer? I don't like to perseverate on the idea that we're going to have to demonstrate our knowledge on those spring tests that we get to take, but our students very often have to be able to read something, look at a graph or a table, and then provide an answer. And so if that's the case, this is an opportunity for me to help build that skill set of how to approach things like that in life. So we want to map out our questions, collaborate like we talked about with others as often as you can. We have some resources that we're going to share with you in a minute, but I know that you guys many of you have heard of the UCube data talks. If you just Google that, but this is actually a link, and we've put the we put the slides and the handout in the Melanie, we've gone dark, but we put the slides and the handout in our handout section, the slide deck. But UCube has some amazing ones, and one of my favorite is this one. Right now I use this a lot. Some of you might be familiar with Cuisenaire rods, which is what's being modeled down here as the key. But I want you as participants to look at this visual. And I want you just to answer something that you notice from this visual, just something that you notice. If you'd go ahead and put that in the chat, something that you notice. Let's start with that. So noticing equivalent fractions. noticing the numbers 1 to 10. I'm noticing that there's some that have the same color and some that have very different colors, right? I noticed that 2, 3, 5, and 7 only have only have 2 colors, okay? I notice they all have white color blocks with them too. You notice prime and composites. There's some patterns, absolutely, right? So that's our noticing, getting our kids to connect with it, right? And then I would proceed with the students and ask them, what do they wonder? And this is where I get to get a glimpse into what are they thinking, right? What is their current connection with this visual, this data? And when I ask the students, what do they wonder? I want to be very careful in reviewing these questions so that I can see how do they support the pathway that I have in front of me. If I'm using this with my 3rd grade class, I'm using it to talk about multiplication. I'm using it to talk about some different relationships and some patterns. So if I'm doing that, I can see what those questions are that would be related. So I might ask my students, why does 2, 4, 6, 8, and 10 all have red rods? And then my next question could be, what do you think they represent? And my students can use this, right? And so I think that our students can use what they know. If they can figure it out with 2, 4, 6, 8, and 10, it's likely that they would be likely, but I can't guarantee anything, right? That they would make the same connection between 3, 6, and 9. But I might be able to ask them, what other connections can they make to the colors? And I start having my students do this. And we can use this, we could use this with our younger kids, right? For addition and those kind of things. We can use it for multiplication, but we can use it for prime and composite. There's a lot of ways we can use this data talk. But once our students have made this connection with this visual, I may be using this before I even introduce my Cuisinart rods as one of my tools in mathematics or something like that, and having my students make sense of it. But my whole point is I want to know what is my end game in mind, and then map out some of those questions that I can have and plan for. And so this one comes, and we put the link down here from the UCube data talks. It's a visual that Joe they have on the UCube website, and there's always a key. And I think that that's very important. We could ask the students, what on this visual would be the key, and why do you think that? Let them make connections and see the value of seeking out that key. If there is one, there isn't always a key, but there's very often a key. And so, but let them, what could be the key and why do you think that? In this, I had students tell me that the key were these white bars. They were on, each one had its own key. I had not thought of that, to be honest with you, and completely transparent. But the students said the white bars are the key because they all have them. And so it helped determine the value. And for a student to come up with that and think outside of that, and then I asked them, how did their key translate to the colored rods? And so then they were making connections with that. But to give the students an opportunity for that voice really gave me insight into what that student was thinking, which I thought was amazing.
So here's another one. Can you guys hear me?
Yes.
Okay, good.
I can hear you now.
Okay, good. Just take a moment, and what do you notice and what do you wonder about this particular set of data? Go ahead and put that in the chat. They're all round. So now I'm going to ask, what's all round? Is it the shapes inside, that they're in circles? The banana is the largest. There's different kinds of fruits. Some are bigger and some are smaller. Absolutely. Right. And so in this particular setting, we want to look at the size of the circles. And so, like Catherine said, if I'm looking at what this key is here at the bottom, I see the larger circles are the most popular. Can you hear me now? Am I still here? Okay,
Yes.
good. So now we can have all kinds of conversations at the elementary, but now let me talk about some proportionality. right? If I can start creating some data sets. So if I'm going to the store and
Oh, let's still
I'm
at it.
going to create a fruit salad, or if I am the store manager, what types of fruits should I be ordering and in what quantities? So I can have some type of proportionality. I can start graphing. I could have bar graphs. I could have all kinds of different ways that we can look at how do I interpret this data, right? So I can talk about optimization. Like if I only have this capacity, I want to make sure my bananas and apples, those are in abundance, right? And so we have those kind of conversations. What does that look like if I'm only allowed this particular budget? Or the strawberries cost this much, and how does that affect other people? Yes, unfortunately, there are no raspberries, but there are blueberries. So where might raspberries fit in that particular setup, or where might a pineapple fit? So all these different ways that we can start engaging in conversations about this data, right? We really want to talk about here where size does matter. So how does that affect what we have with us? So here's another opportunity that we can take this one. We can take this one K-12 too. What does that look like for our students? This is something tangible. When I go to the grocery store, I think about it. The display at Stater Brothers has a whole section of just apples, and I've seen strawberries on two sections. But there's like a little skinny section for the mangoes and a little skinny section for the nectarines. So why do they do that? And here's some data why, right? That my claim, evidence, and reasoning is important.
And then we did talk about their
Oops.
reasoning with that key at the bottom, Melanie. If the smallest circle represented 5% of the population, or what would the smallest circle have to represent in order for this to represent 100% of the population? So we, depending on the grade level, we could take it to a variety of places and let the students really wrestle with some of these questions. And this is where I think it's valuable when they are put in small groups, 2 to 3 in a team, and try some things out. If I'm saying it's 5%, would that make sense? So then what would this banana be if this was 5%? And what all those values, and could they then take and compare what they projected to what it was actually? And actually,
great question,
absolutely.
Jolene.
Yeah, I like Jolene's question with cost as well.
So here's another one. Could go all kinds of places. So take a moment, and I just want you to reflect on that. What do you notice and wonder about this particular set of data? Right. So science question: How does season affect the choice? I love that. To be honest, I had never seen a graph like this until, oh wow, but it makes sense. The visual aspect of it. Yeah, definitely water used in a certain time. And as someone who's just had their water turned off so things can be fixed, when you need some water if you don't have it, for sure. Right? And how much does each take? Are these are all different water events, but do they take the same amount of water each time? Or what do we do? How do we average? So lots of different ways. And does the time matter? Right? I see that inside is the morning and outside is the afternoon. So what can I do with that? How do I graph that? We can take that all kinds of ways. We can talk about the math. We can talk about the science of it. Just lots of opportunities that we have with our students to engage them. So with that, we hope we've given you a lot of different ideas that you can use. Here you have some resources. I love New York Times, what's going on with this graph. They even right now have a section all about coronavirus and what that is doing. So if you need something relevant, here's some data about what's happening right now. Creating a graph, National Center for Education Statistics, this is a great place to go. More information from Kids Britannica graphs. And then, of course, Joe Bowler's UCube data talks. Those are another great resource for you to use. So we want to say thank you so much. We really enjoyed hanging out with you today. You got some really great questions, and we want to hear more about how you've taken this and used it into the classroom. So we want to say thank you and have a great rest of your conference.
And the resources are in the handout. Sorry, Melanie.
Yes.
The resources are. So thank you guys very much.
Yes, thank you.